because we are aware of these being of import to us when it comes to the examination, even Olympiads. So we'll be taking few questions before we move on to the next topic, which is in offing, and the next topic being ray optics, wave optics. But as per the request, let me take a few questions for this class, this lecture, to reinforce whatever we have studied vis-a-vis EMI and alternating current. I'll be taking few questions to begin with. Write down a capacitor with capacitance C. A capacitor with capacitance C, a coil, and a coil with active resistance R, inductance L, and a coil with active resistance R, inductance L, are connected in parallel to source of sinusoidal voltage of frequency omega. The first ask will go in turns. So I'll limit to first ask. The first ask of the question is, find the phase difference between the current fed to the circuit, and the source voltage. The current fed to the circuit and the source voltage. So how we'll go about it? Well, how many components are there? There are two components as per the question. The author have accorded you two components.
Sir, before we proceed with this question, can I ask something?
Sure, please do.
Yes, yes. So basically, whenever we study an LCR circuit, we study the components connected in series. I have a few confusions about basically when the components are connected in parallel. Could you just like briefly take up the topic once before we continue with this?
Sure, without doubt, we'll be taking it because series being taken in general, parallel I don't think they get elusive about. So we'll be taking parallel combination as well. Rest assured.
Yes, sir.
As part of the course, why we are going for question deliberation. Good.
Yes, sir.
Okay. So in this question, how many components? In fact, the questions which I have allocated, you'll get a parallel combination here. You're not going to get series combination. We are referring to there being two components, right, Vasudev? One is the capacitor and the other is a coil.
Yes, sir.
One is capacitor and the other is a coil. The author has given you two components over here, capacitor and coil. That coil has got R and inductance to it. That coil has got R and inductance to it merit. By the way, to the serendipitous discovery, Vasudev, what you asked is what you are getting served with this question, and that being parallel combination. So we are taking parallel combination in toto. There will not be even a sliver of doubt. Without of this being taken would have been many litany of demand, but after of this, post this question will not be even a sliver of doubt on parallel combination. I assure you on this. What is being given to you is there is a capacitor, and that capacitor is in parallel with a coil which comprises of R and inductance, right?
Yes, sir.
So just to check what basically the author is into ask, The author is asking about there being a capacitor. So this is a capacitor I take. And then there being a resistor and inductor. R here, L here, C here. Why do we have doubts related to parallel combination? The answer being, where lie the answer, I would say, is we not relating it mathematically. We'll be relating it mathematically, and when I say mathematically, I mean complex representation, complex number representation. How do we go about it? Let me ask you, in this combination, if it's asked, as I'm taking in turns, if it's asked, find impedance, find Z for the circuit shown. How will you go about finding Z for the circuit shown? It is in parallel combination, right?
Yes.
So what are we to write? We are to write 1 by Z.
That applies, yeah?
As
1 by Z
Yes,
effective
dear?
is equal to 1 by Z1 plus 1 by Z2.
Yes. Is equal to 1 by Z1. And what will be 1 by Z1 is important. As Z1, I'm referring to capacitor. What will be 1 by Z1? 1 by Z1 will be 1 by minus of J XC. Now, this is important to understand. XC is Fallon conclusion, 1 by omega C, we are aware of it. Why do we have over here that minus J sign? That comes from complex number, you must be aware of. If you are rotating it anti-clockwise, you'll multiply it with J. If you are rotating it anti-clockwise, you will multiply it with minus of J. It comes from the complex number Euler methodology. E raised to the power J pi by 2 means rotated anti-clockwise. Minus of J pi by 2 rotated clockwise. So if one I am to take clockwise, the other should be anti-clockwise. For capacitor over here, it is in the sense minus J. Then for the other component, what I should write is an obvious 1 R plus J XL. Are you in concurrence?
So,
Do you concur to this, Vasudev?
so what is J again?
J is e raised to the power J pi by 2, Vasudev.
So you're saying
This is
J
what
is equal to E raised to power J pi by 2.
Yes, when we are to multiply e raised to the power I theta, I think you can recollect. I told you that we write it in the terms of imaginary of this part, and we have a knack which should not be carried as it inflicts confusion to drop imaginary, write it in solo e raised to the power I theta, the representation that we have for current or voltage, correct? Sinusoidal representation, right? Yeah.
Yes, sir.
If I multiply this with this factor, which is nothing but J to me, then what I'm doing to this, I'm rotating it anti-clockwise by pi by 2, correct? Yeah.
So 1 second, when the thing that you are hovering your mark over right now, is it e to the I pi by 2?
Yeah, it will be I pi by 2.
Yes, that just looked very convincingly like a J.
I or J, whatever you mark, I pi by 2.
Yes, sir. Okay.
Okay. So multiplication will make it rotate.
By pi by 2 and division will make it
Anti-clockwise by pi
rotate
by
anti-clockwise clockwise by pi by 2. Yes, I get it.
That's the principle I am to apply over here. Am I clear with this one then?
So just 1 second.
Yeah.
So if
One is down, let us say capacitor is up, then inductor should be down, right? Yeah, pure capacitance, pure inductance. Pure capacitance up, then pure inductance will be down. You can take voltage or can take potential difference as a reference, correct?
Yes, sir. So just one second. When you say XC is just a scalar, right?
Yeah, X is scalar. It is 1 by omega c. XL is scalar. It is omega L. But the representation is on a complex plane. We are representing impedance. Impedance will have a real and an imaginary part, right? Yeah.
Yes, sir. Okay, I get it.
So real is this to us, this being imaginary, correct?
Yes, sir.
If one is up, the other should be down. So if one is with J, the other will be with minus J, right? Yeah.
Yes, sir.
Okay. Once this being understood, things are to fall at place, Vasudev. Now nothing much left. If you know of this presentation, you'll be able to sail through easily. And that being, what you do next? You just write it down in consonance with what you want it to be. Generally what they do, they can write it as JXC, right? Do you check?
Yes, sir.
Okay, this is nothing but JXT. And this remains R plus JXL, right?
Yes.
We can go ahead with finding Z from here. What will be Z from here? I'm taking steps. R plus J omega L. Simple mathematics now, nothing much left. Divide, this is the denominator. What it is upon? R plus JXL is upon what factor?
So, could you take the camera down a bit?
Oh, sorry. Okay.
So just one second.
Just cross multiply.
How did I didn't get the first step? How you went from the RHS of 1 by C to what's just below that?
This one, second one.
Yeah.
This is just multiplying with J. J square is equal to minus 1. Correct.
Okay, but how did X C, that which was in the denominator, go to the numerator?
XC is 1 by omega C, right?
Yes.
So omega C will go up, right?
Yes, so that'll still remain 1 by XC.
This is omega C. This is omega C. Not XC, omega C.
Okay.
Good now?
Yes.
Okay. So what do we get from here then? Just cross multiplication. Omega R C J, let's say J, I'm writing it over here. Omega R C J, then minus of omega square L C, right?
So camera.
And plus of 1, right? Just check once.
So can't see it.
Right?
So just 1 second. So you need to move your camera down.
Right?
So I can't
Come
see.
again, please.
So you need to move your camera down.
Okay.
Okay, yeah.
Can you now?
Yes, sir. 1 by C. Yeah, that's. So wait 1 second. R plus XL. Yes, okay, fine.
Now, dear, you have what to do with Z. I think you can simplify it. Will you be able to simplify? See, now what I'm asking you to do is, as per the question, if I am to position what will be the phase difference between current fed to the circuit and the source voltage. Now, current fed to the circuit and source voltage differential we are to get. What to do, how to get Z conducive to our finding, that you will tell me better, dear. What shall I do over here? Shall we multiply it with conjugate so that we get the denominator free of J? Shall we do that?
Yeah, sure.
Yeah. So multiplying it with conjugate, we will be freeing denominator of the J factor. It'll be absorbed of the J factor. May I erase this?
Just 1 second. I'll write down the last step. C J. Yes, sir.
Okay. Nothing radical left now, by the way. It's all cosmetic. We have to find what will be Z. So multiplying and dividing will get us what? Tell me once. You only do tell. Multiply and divide. See what you're getting. I want to free. I have to absolve. Numerator will be having J in it. Denominator should get absorbed of it. That is what I'm looking forward for.
Yes.
I reckon what you have to do, and thereafter you have to find just tan theta or tan phi, right here.
So 1 second. J squared is -1, right?
Yeah, correct.
Okay, so the denominator becomes r squared plus xl squared. And the numerator, I mean, do we have to expand this? It looks like it isn't going to be neat.
It's not required, but then how will you be able to find the differential on phase? I'm just writing it down for you. Nothing much. This is the factor and minus of, let's say, J omega RC, just the conjugate. Right.
Yes.
Okay. And then will be divided by the same factor. 1 minus omega square LC plus J omega RC being there. And this should be multiplied with the negative factor of it, right? So 1 minus omega square LC minus J omega RC. Do check right here. Nothing much, it's mechanical now. Right?
Yes.
Now tell me, what will it be? Well, I want to find tan theta, dear. You can find tan theta for me. Come on. Anyway, denominator doesn't hold water. Denominator doesn't hold water, right, dear?
Yes, it gets cancelled out. So.
Yeah. What is tan phi from here? Let me skipping a step, ask you on tan phi.
Yes, so tan phi is the coefficient of J divided by the constant, right?
So what will that be? Omega C R square plus omega square L square minus omega L omega J omega, okay, divided by, now this to me is, how much is omega L? Done. Oh, only R.
So 1 second. Phi. Could you explain how you wrote the numerator again?
Yeah. Which one? This one, right?
Yeah.
I'm expanding it.
No. How did you write tan phi? Because I wrote something different.
There will be the component here, J component by, I'm getting over here J component as omega L, right?
Oh, that's omega L. So, okay. All right, fine. It looks a lot like omega C.
It's omega L. R plus J omega L, right?
Okay.
Is it fine? Is it good with you now?
1 second. Omega C, omega squared C squared minus omega L. Okay, shouldn't you get omega L 1 minus omega squared LC? You've written R squared plus omega squared L squared.
Okay, this one.
Yeah, no, if you're taking the J component of the numerator expression, you should get omega L times 1 minus omega squared LC, all of that minus omega RC.
I have to firstly multiply it, right?
Yeah, so we can just multiply the j part, right? Because the
Yeah. The
expression in the
J
right
part.
parentheses does not have a j.
Hmm.
So we can
So
just
where
multiply omega L times 1 minus omega squared LC.
okay, so where is the correction to be made? R square, I wrote R here.
So, but that would be a constant, right? So I'm saying the numerator should be omega L times 1 minus omega squared LC minus omega RC.
Then look at over here, what I'm trying to suggest is, let us expand it. Fine. What are we getting? R, right? Minus R omega square LC, right?
Yes?
Plus J omega L minus J omega Q L square C and minus J omega R C. And then whatever is the denominator, let me mark it as something.
Yes, sir.
Let's say A, right?
Yeah, sure.
This is not no more tan house tan phi. So from here, this is Z to S. Now tan phi from here, tan phi will be what to S? Will be the J part. So J part being omega L
Yes, sir.
minus omega Q L square C, right?
Yes, sir.
And minus omega RC.
Yes, so this
This
is
should be
very different from what you wrote initially.
okay, okay. R omega square LC.
Yes.
This is what you
This,
got, right?
yes, this is what I got.
Yeah, correct. This is the one. Fine. So we got the differential.
Yeah.
Right here. And then the second part, would you read it out to me?
So the second part?
Oh, second part I didn't get you, right?
No, you only gave me the first part.
Second part. The first part of the question. The second part is an ask on right now.
Yes, sir.
A circuit consists of a capacitor with capacitance C. It's a repeat actually of what they have said in the earlier, the aforementioned one. In the earlier, the segment that we took earlier, in that segment, what they have said is a repeat of it, though I'm just reiterating in a way. A circuit consists of capacitor with capacitance C and a coil with active resistance R, inductance L connected in parallel. Find the impedance at frequency omega of alternating voltage. What will be the impedance? It's no brainer, I presume. We have already gotten the impedance, right? Yeah.
Yes, sir, we've already gotten the expression.
Yeah.
So you just need to
It's
substitute
already
omega
there.
and be done.
Yeah, that's it. So this one being done, so we move on to the next question.
Yes, sir. So just one more of a semantic doubt here. Z
Yeah.
is a scalar, not a vector, and what we got there was a vector expression for Z. So how do we reconcile with that?
C has got a real component and a complex component, imaginary. So it's not a vector quantity, but what it represents, phase. What is phase to us? Phase, as I told you, is a vector which is rotating. So when I write I is equal to anything, max, sine of the angle omega t, and try to represent it in phasor form, then how we represent it is what is for us of great import. We want to present it in imaginary form, Euler form, complex number form. So we write it down as this, and imaginary of what form? E raised to the power j omega t. I think this is allowed.
Yes, sir.
And then the rotation part taken into account. What am I to do? If I am to present capacitor, we'll rotate it clockwise by pi by 2. If I am to put inductor, I'll rotate it anti-clockwise pi by 2. Accordingly, I'll multiply this with e raised to the power j pi by 2 or e raised to the power minus of j pi by 2. Now, this is what I'm to represent Vasudev on a complex plane.
Yes,
So
sir.
if I'm present on a complex plane, I have got the real part and I have got the imaginary part, correct?
Yes.
So this is real part R to me, and this is imaginary part to me, correct?
Yes.
So this can be J omega L, let's say, or 1 by whichever is higher over here. This is the part, which is what we have read, right?
Yes, sir.
Now coming to parallel combination, any combination as we cited earlier. I take this combination, that is. So for this I write, as usual, I will write it as 1 by Z1, fine. For this I will write 1 by Z2. Z1 is what to me, there is no real component, so it will have only imaginary to reflect. Here Z2, what is Z2 to me? So take again the phasor plane and check for yourself. This is R and this is JXL to me, right? So what will be combination of the two? The combination will read R plus JXL, right?
Yes, sir.
R and J over here means it's rotated anti-clockwise by 90 degree, correct?
Yes.
So this is what we write, the real, imaginary, and it will shape to Z2 later, will calculate Z. So vector or scalar is not over here in doc. What we are to take into consideration is how to present the real, how to present the imaginary part. And for representation of the same, we are making good of complex theory, complex number.
Yes, sir.
Getting it, dear?
Yeah, for the most part.
Not, I think you're not convinced. Please convince yourself. Only then we are to move ahead. If not, I'm open to deliberation. Please come with your doubt, dear. Don't hold on to yourself. Yeah, I want the argumentation to continue. Please do.
So just a second. Let me just catch a hold of my doubt in the first place.
Sure. Yeah, I need to also get a hang of it.
Yes, I think I'm good.
Okay. Shall we take on to the other questions in the repository?
Yes, sir.
So taking the fight on to the other question, and why I call it a fight, because these are the questions important vis-a-vis understanding of the concept per se. Other than these, there is nothing in the circuit diagram or alternating current theory per se. We need to get a hang on theory through the questions. So the second question, which will reveal to you much more than what the first did, speaks of, write down, a capacitor with capacitance C equal to 1 microfarad. I'm trying to position it to your Ask Vasudev, well incommensurate with your parallel combination ask. A capacitor with capacitance C equal to 1 microfarad.
Yes, sir.
And a coil with active resistance R equal to 0.1 ohm. And a coil with active resistance R equal to 0.1 ohm. And inductance 1 millihenry. And inductance 1 millihenry are connected in parallel to a source, of sinusoidal voltage V equal to 31 volt. V equal to 31 volt.
Yes, sir.
Fine. The first one. frequency omega at which resonance sets in. Very simple ask. Frequency omega at which resonance sets in. This is R, L, C. You're aware of what to do vis-a-vis first ask Vasudev. Frequency omega at which resonance will set in. And for resonance, you are aware, for resonance to set in, the first ask is to get Z from depiction. What will be Z from depiction? Why do I say Z from depiction? Because at resonance, impedance should be minimum. Correct, dear?
Yes, sir.
Let us find impedance then, taking a cue from the previous dispensation. If I take a cue from previous dispensation, what I am to do is to rerun it. 1 by Z, let us rerun. 1 by Z is equal to what to us? 1 by minus of JXC, right, dear?
Yes, sir.
Plus of 1 by R plus J omega or XL, let us say.
Yeah.
Omega L or XL. Which will boil down to, you're again aware of the same, 1 by R J XL plus J omega C, right, dear?
Yes, sir.
Now for resonance, what we have to do, Vasudev? For resonance, impedance should be minimum, right?
Yes, sir. So just differentiate this and set its first
Because
derivative
we are
equal to 0.
differentiated, right? So what do we do? Differentiation with respect, either you can do either Z or 1 by Z. Differentiation with respect to omega, right? Yeah.
Yes, sir.
This should be maximum then. If one is minimum, if impedance is minimum, then 1 by Z should be maximum, correct?
Yes.
In either case, you have to equate to 0, right?
Yes, sir.
The preliminary being you have to equate to 0. Okay, you get from here what? Please let me know.
Yes, sir. So 1 by C basically becomes R plus J omega L plus J omega C. Now, if you differentiate that with respect to omega, yes, you should be getting ln R plus J omega. You just treat J like a constant, right?
Yeah.
Okay. Yes, 1 second. That by JL plus JC. So you should be getting the natural log of R plus J omega L divided by JL plus JC. And
So are we? Yeah. Carry on.
And that should be equal to 0. So you get the natural log of R plus J omega L should be equal to, wait, this is not right. Okay, no, never mind, there's a minus that gets cancelled out. So the J is cancelled out, the minus is equal to LC. So you get R plus J omega L should be equal to e to the LC minus R by JL. You get omega as e to the LC minus R by JL. But that has J in it. How can omega have an imaginary component?
Exactly. Take your calculation, dear. What did you write 1 by Z to be? 1 by Z as usual, whatever we have gotten, you have marked it as, I presume, JC, right? If we differentiate it, We're differentiating 1 by z, right, dear?
Yes, you get JC
So
plus
j
ln.
omega c will get you jc, right?
Yes.
J omega c when differentiated will get you jc.
Yes.
What about the first factor? First factor, when you differentiate, then you will be getting minus of jl divided by r plus j omega l whole square, right?
Wait,
Yeah.
just 1 second. I did a big blunder here. I did integration instead of differentiation. Okay. My bad. We've been studying differentiation lately, so
Yeah,
I
but you're
integration.
You're being slightly taxing on self, yeah.
Okay. Whole squared times the derivative of that is xl. Squared, yeah, okay. So you ultimately get minus xl is omega l r plus j.
Vasudev, you being such a pedantic stickler to accept your mistake. How is that you are so quick to accepting it when it comes to class?
Sir, I didn't get you.
You are so pedantic stickler on accepting your mistake is what displays your writing. You're writing in DP. Then how are you so easy on accepting it in the class?
Okay, I wrote that a couple of years ago. Maybe I've changed.
Okay, nevertheless, let's get back to it. So I think you will be getting r squared plus omega square l square is equal to 1 by LC, right? Yeah.
So could you come again? R
L by
squared plus?
r square plus omega square l square is equal to LC. Didn't you get that? And differentiate this.
Yeah, we just, I'll confirm.
Differentiate this, nothing else.
Okay,
Minus of j l over here, when differentiated, r plus j omega l whole square. Do you concur with this?
Yes, sir.
First one.
Yes, I do.
And second one will be jc. We will be equating it to 0.
Yes, sir.
So what do we get omega from here? We get omega or omega resonance we can write because we have equated to 0, so better omega resonance we do right.
Yes.
1 by LC minus of r squared by l squared. And by the way, this is something which is to be committed to memory, yeah. Very important.
Yes, sir.
1 by LC minus of r square l square is a mechanical arrangement to us. Okay. For this arrangement, omega resonance is this to us. This keeps frequenting. Got a knack of appearing and reappearing.
Yes, sir.
Okay, dear. So this is the first task. We are through the first one, right?
So just 1 second. So okay, J cancels out. That goes outside. Omega L by C. C is equal to that. Is equal to that. Sir, if you do solve it, I do not think you get that.
You getting?
No. Okay. First of all, J cancels, so you get R plus J omega L is equal to square root of L by C, right?
Okay.
R plus J omega L is equal to square root of L by C. From there, how do you get that equation? How do you get that expression you've derived?
Okay, let's differentiate and check. What do we do over here? I'm differentiating this part first, right?
So why are we differentiating that again? That's the derivative. We've set that equal to 0, right?
No, this is to maximize. We're differentiating because it's resonance being asked. Yes, they want you to find. So this 1 by z with respect to omega, omega is the variable, right?
Yes, so we've already differentiated, right? The equation you've written is the one that's already been differentiated.
Yeah, this is differentiated. I'm equating to 0. I'm not differentiating it.
Yes, sir, yeah. So
equating to 0.
Yeah, when you solve that, you do not get the solution that you've written. I'm getting something else.
Okay, let us figure it out. So this was the term with us. We have differentiated already. We got this, right? This you are in concurrence with?
Yes, that I'm in concurrence with.
Okay. So what I do now, I take it to the right side. So L divided by R plus J omega L whole square is equal to C, right?
Yes.
Okay. And then what we have to do, we are to find what will be omega from here, right?
Yes, sir.
So what shall I do in order to get the J factor of conjugate again?
Yeah, okay. So,
Cannot take the J factor along, right?
yes. So, but then you can't completely get rid of it, right? Even if you do take a conjugate, some residue will remain.
So minima, when I have to take the, what shall I do? I'll have to equate it, right? The real factors should be equated. I'll have to square it, right?
Yes, sir, sure. But all I'm saying is you'll still get to
Like
J. I do not see how we can find omega where the expression for omega is bereft of J.
I'm taking L by C over here, and then I'm
Yes.
marking it as J omega L whole squared. Okay, dear.
Yeah, sure.
Okay. Now J omega L whole square. What will be this to us? I want the real part of it, right? I want the real part of it.
Okay.
The totality. One is this way, the other is this way. This is R and this is J omega L. So what will be the resultant? This will be the resultant, right?
Yes.
So resultant will be what to us? R is square plus omega square L square under the root, correct?
Yes, sir.
So what we are doing is we are multiplying it. We are finding R plus J omega L whole square, and I am equating the magnitude now. So this will be removed by the magnitude, which is R square plus omega square L square under root of it whole square, right there.
Oh, okay. So,
Got it?
could you take the camera down a bit? I think you've written something which I can't see.
Is it come again?
So, can you just pan the camera down?
Yeah, sure.
Okay, that doesn't fix it.
Okay. Any luck now?
So, no, you just need to take it a bit more down. Yeah, okay,
Down.
that's all right. That's all right. Okay, L by C. How did we just get away with replacing R plus J omega L with its magnitude? That's the part that's bumming me right now.
Okay. So I'm equating it to L by C, right, dear?
Yes.
Left hand side, you are having L by C, which is real, correct?
Yes.
Now the right hand side is having R plus J omega L squared. How you decode R plus J omega L? What is R plus J omega L squared to us?
It is.
What does it mean?
It's a complex number.
It's a complex number, correct. So R plus J omega L, this being R, this is R to me, this is J omega L to me, right?
Yes.
We are adding to R J omega L, correct?
Yes.
Which is to get me a vector quantity, right?
Yes, sir.
So I am to find what of this vector, a vector of which magnitude is to be gotten, right? I am finding the resultant.
Yes, sir.
I am finding the resultant. This is R, this is J omega L. I have to find the resultant. That is what it means, a squaring of a vector quantity.
So the way I learned it, the squaring of a vector quantity basically just involves the squaring of its magnitude and the doubling of its amplitude or its argument or its angle. So that will still yield another complex number.
Let's say I present one to you, and then better, I need an information on this one, the complex number. What have you studied about the complex number representation with this notation, R plus J omega L or omega, whatever it may be, R plus JX. If I am getting your complex number X plus IY, right?
Yes.
And then we ask, what will be X plus IY whole square? What is your answer to this question?
So it'll be just manually squaring the terms, x squared minus y squared plus 2ixy.
Minus y squared plus 2ixy. This is what
Yes.
you'll be doing?
Yes.
So this factor, according to you, they are in alignment. It would have been the same with x plus y as it is over here. You have, or we have rather, dismissed the part that they are making what angle with each other. To me, this means what? X plus iy, the magnitude of it squared.
Okay.
This is a vector A dot A is A squared to me, right?
Oh, okay, we're taking the dot product.
Yeah, in a way, that is what we are doing. This is a vector quantity, right? If you square a vector, dear, right? What do we get?
Yeah, okay, no. That's that. All right, wait. Okay, initially we were just squaring a complex number, and we are interpreting that as taking the dot product of a vector with itself. I don't. I mean, but both of them yield different results. If we took the mathematical squaring approach, we would be equating a real number with a complex number, and that would only be true if omega became zero. It would make the complex part zero, and it would allow for the two real parts to be the same. But if we take the dot product, it makes both sides real, and you can actually solve for omega.
Yeah.
Okay. I'll have to research this. But fine.
Omega cannot be variable. See, if you're a vary omega, you're free to vary it, but then you'll have to go into the electronic segment, wherein it's possible for us to vary omega. That is another segment of electrical engineering. Over here, we are fixing omega.
Yes, sir. I'm not still completely convinced about this, but I'll play along for now.
Take your time, dear. No issues. I'm not rushing through it.
No, I think the kind of
These are the nuances we need to get a hang on, right? Yeah.
I think the kind of mental confusion I have will only be resolved with a cup of coffee and an hour of contemplation. So I think I can move on for now.
I told you I'm in no hurry, and we need to look into the nitty-gritties of it. That's why being taken in detail, and we are trying to get to the position wherein we should be delving for a longer period on it. So I'm open for any deliberation, and for as long as you want, I'm willing to delve. Okay, dear?
Yes, sir.
Okay?
Yeah, okay.
So you can. You contemplate tea leaf. Why coffee? You can contemplate tea leaf now. Right? You know this phrase, contemplating tea leaves?
Yeah, I do know that. I mean, I looked it up after watching The Prisoner of Azkaban.
Okay. And you know this, run with the hare, hunt with the hound?
Yeah, you taught me that.
Yeah, okay. So this being the one, and then what do we have? We have the other side. So let's move on to the other segment. You want to ponder for
I will ponder on this, and I will ask you my once I've been able to crystallize what's happening in my mind. Yeah.
That'll be brooding. That you take your time. I'm asking for pondering. Pondering is for a shorter period. You can brood on it for long, no issues.
Okay, and I think I'm done pondering. I'll brood and come back to you with the results. But for now, I think we'll move on.
Okay. So I'm moving on to the second part then, Vasudev.
Yes, sir.
To square it up, now we have the effective value of fed current in resonance as well as the corresponding current flowing through the coil and through the capacitor. That's a given right here. We know that. Isn't it? Once we are convinced with what will be omega resonance, then we can find the effective value of current fed at the time of resonance, right? Yeah.
Yes.
What will it be? Tell me, just you can get an elucidation on the same. What will it be? Effective value. They are asking for the effective value of fed current at resonance or in resonance.
So won't it just be V by Z?
Yeah, that's V by Z, right? Yeah. That's it. Well, that's what we have.
Yeah.
And then What about the current flowing through the coil and through capacitor?
Okay, so since they're connected in parallel, again, we can fall back to the concept of treating them independently. We can apply V is equal, I is equal to V by Z, but Z of that specific branch.
Yeah, that's it.
Yeah,
In one case, it'll be XC simply, right?
yes. And in the other case,
And
it'll
the
be an
other case,
amalgamation of R and XL.
yeah, that's it. Fine.
Yeah.
Should we keep to this today?
Yes, sir, sure. And actually, I wanted to ask you this for a while. Can you, like, from the next class onwards, instead of starting wave optics, I mean, you could, of course, if you wanted to. But what I wanted to ask is for you to do thermodynamics. I mean, from the basics, from the ground up, because I have so many confusions in the subject. I'm not even able to read the theory and understand it properly.
In absolute agreement, dear. All ears, no issues. We'll first get done with thermodynamics.
Yes, sir. So, like,
And then
from
only
the ground up, from the
yeah,
basics, all the way to what we need.
from basic, right from scratch, dear.
Yes, sir.
Okay, you are known to the dispensation out here, right, dear?
Yes.
Is it in odd starting from scratch ever it has been?
So you might be under the assumption that I have completed some prerequisites. I'm just telling you outright that I haven't.
I will nip that in the bud. It will not be taken that way. We'll be starting from scratch and then we'll take towards the culmination. Only then we'll go for the topic optics. Okay, dear?
Yes, sir, sure. Thank you.
Rest assured. Rest assured. And many a congratulation. Let's keep our finger crossed. I think you're through anyway. You're getting certificate, right?
Yes, I am getting a certificate. I think that's if you score anything more than 10, you'll get a certificate.
Yeah, that is fine, but you'll be through as well. 21, I think you will make it.
Is it? I think the cutoff. I was told the cutoff would go as high as 23.
I have seen in 1918 it was around 21. 19 it was 21. 18 it was less than 21. I'm hopeful. Let's see. It depends. I think they will reveal in a day or two.
Yeah. And today is the last day to challenge results. So I guess they're just waiting on that. Maybe they'll reveal it tomorrow or the day after.
Have you anything to challenge?
No, not really. All of the solutions check out. I tested them.
So all the best, dear. Yourself.
Yes, sir. Thank you.
Okay.
Good night.
Thank you, dear. Bye, dear.